I'm going to start off just kind of introducing you to Go. And if you've never heard of Go before, it is an open source programming language that makes it easy to build simple, reliable, and efficient software, and it has rich built-in concurrency support. Go is great for a variety of different applications, including cloud network services and web development. If you want to learn more about getting started with Go, you can go to go.dev/learn and find some resources there for getting started with Go. If you want to be programming in Go in VS Code, we have the VS Code Go extension. This uses open source Go tools to provide language and debugging features for you when you're developing Go projects in VS Code. And this is maintained by the Go team at Google. And I'm a software engineer on that team. We have some exciting new things happening in the extension recently. So in 2021, earlier this year, we enabled the Go language server, also known as Go Please, by default. So this provides most of the language tools. So completion, auto completion, and many other features that you'll see in my demo later in this presentation. And then the other updates we have are we're currently working hard on debugging improvements. So we are currently working on a debug adapter that is written in Go. So this is going to provide native debug adapter protocol implementation within the Delve repository, which is the Go debugger. With that as the intro, I'm going to go ahead and get started with the demo. And with this demo, I'm going to assume some familiarity with VS Code, but if you want to follow along and see how I'm getting to different parts of the VS Code UI, I do have the screencast on so you can see what shortcuts I'm using to, for example, open the command prompt. So I'm starting a new Go project. So the first thing I want to do here is to initialize my go.mod. And so what this go.mod is a file that defines a module. And so a module in Go is essentially just a group of packages that can be versioned together. So this is the Go solution to package management. So the name of the module I enter here in this command, and this is usually just where your code lives on the internet. So once I've run that command, it's going to create this go.mod file for me, which includes that module name that I entered and the version of Go that I'm developing in. And you can see that this matches this item in the menu bar at the bottom. I have this code lens at the top, and I'm going to go ahead and click it. And what this code lens does is it checks this workspace that I'm working in and make sure that I have all of the dependencies that I rely on defined. And so there's already some code in this project so that relies on this tools module. So it's added that dependency for me. Now later, if I want to manage my dependencies, I can come here and upgrade these dependencies and make different changes that way. So now that I have my project set up, I want to go ahead and start writing some code. So I have this file here in my project called hello.txt, and I have a string in this file. And what I want to do is I want to reverse this string. Pretty simple, but we're going to write the code to reverse the contents of this file, and then we're going to go and debug and test. We're going to test the function and debug it. So I want to define, I know somewhere in my project I have a function for reversing string contents. So I'm going to use symbol search to look for this function. So I type in reverse, and I see that I have this defined in my module in this string util package. So I'm going to go ahead and click on that, and that's going to take me to this file where reverse is defined. Now I can go ahead and define my function. So I'm going to write the function signature. And as I'm doing this, I'm going to be accepting some of the completions that get provided by the extension. So for example, here, string is the first completion, which is what I want to use as this argument type. So I'm going to accept that. And I want this to return a string, which is going to be the reversed contents, and an error, because I might have an error when reading in the file. All right, the first thing I'm going to do is read in the file contents here. And so at this point, I want to use a function from a different package that's going to allow me to read in the file content. So this is going to come from the OS package. And so I type in the name of that package, which is included with the standard library. So it's included in every Go distribution. And I'm going to select this read file completion item. And when I accepted that, since OS is from a different package, we need to include that as an import. And the extension added this import at the top of my file already for me, so I don't have to go up to the top, add the import, and then come back. So I'm going to go ahead and trigger completion here. 1 second. And the first thing that's going to be suggested is file name, which is exactly what I want to use. So I'm going to go ahead and accept that completion. Now I'm not super confident about what this read file function did. I need to double check that all of my assumptions I've made about it are correct. So if I hover over read file, I'm going to get the documentation information. So it's going to tell me that a successful call returns a nil error, which is good to know. And if I want to read more about it, I can open the documentation on this package.go.dev site, and I can see all of this information. And if, for example, I didn't know about this function already, so I already knew that OS had this read file function, I could come to package.go.dev, and I could then search for a package that would provide this functionality for me. So this is a great place to discover packages to include into your Go projects. So I'm going to go ahead and come back to VS Code. And before I continue, I'm going to point out that these red underlines that are happening here, so these are diagnostics that also are coming from the Go extension. And so they're telling me that there are some compiler errors. So if I'm going to open the problems view so we can see all of these errors that I have in this project right now. And we can see that they're all just that I haven't used this variable that I've declared, or that I haven't written a return statement yet. And those are things that I'm expecting. I plan to complete writing this function, so I'm just going to go ahead and ignore those for now. So the first thing I want to do now that I've read in my file is to handle the error. So I'm going to trigger a completion here, and I'm going to get this first completion item that is to help me handle the error. This is a common Go idiom where you check if the error is non-nil, and if it is non-nil, then you're going to return the error. So this has filled in the default value for the string for me and return the error. So I was able to handle that error super quickly and move on with writing this function. So the next thing I want to do is to just reverse the contents of the file. So I'm going to return. I'm going to use this completion I have here, and then I want to return the reverse of content. So I'm going to hit enter. And this completion actually did the conversion to a string for me. So contents, if I hover here, you can see was a byte slice, but reverse accepted a string. So it added this conversion so that I could have the right type being passed to reverse. And if I look at this diagnostic here, I can see that I have the wrong number of return values. And then I can see that there's a quick fix available. I can see that either with this lightning bulb on the left, or I can trigger it with command period. And then it shows me the name of the quick fix, which is here, I'll make it big, is fill in return values. So I'm going to go ahead and select that, and it's going to fill in the rest of my return values for me so that I have the right number of return values. So now that I've written this function, I want to test it. So the first thing I'm going to do is to go to the command prompt again, and I'm going to run this command that's going to allow me to generate unit tests for the function that I'm on. So you can see there's a few other generate commands that I could use in different scenarios. So now that I've selected the generate unit test, I can come here and see that it's generated all of this code for me. So this may be a little overwhelming at first, but what this basically is it's a table-driven test where all we have to do is specify each test case with the inputs and what we expect to get back from the function. And so we can just specify the test cases we want, and then the code that was generated will check that we got the desired output. So I'm going to go ahead and replace this to do with the test case. Again, I see this light bulb here. And so this quick fix is to fill the struct. So it's going to go ahead and fill in all the fields for me with default values that I can just go ahead and fill in now. So I'm going to give this test case a name, hello. I'm going to use that same fill struct quick fix to get the file name here. So my file is at hello.txt, and then I want to get hello world back from that reverse function. Now that I've written my tests, I want to run my tests. One way to do that is to use these code lenses that are at the top above every test function. So these also appear above benchmarks as well to benchmark your code, your Go code. And so I can choose either to run the test or to run the test through the debugger. And so I'm going to choose to use the debug test code lens for now, because if my program crashes in some way, the debugger is going to catch that and then allow me to inspect the state right before it crashed. So I'm going to use that. Okay, so now a bunch of things happened on screen. I'm going to quickly explain what all the different things are. Here in the left pane, we have this debug view, so where we can view our variables, the call stack, and a watch panel. And then below we have the debug console, so this is where we would see output from the test. And in our source, we can see that, in fact, our program did have a crash and was panicking. So we have this pane that gives us the reason. So we see that we had the index out of range error, and it has the call stack. Another place to look at for the call stack that would then allow me to inspect the variables at different frames is over here in this debug view. So if I go to the debug view, I have all of the Go routines that are currently running. So these are the green light threads that are used in Go. And so the currently selected thread has this asterisk here. And I can see that this is also the Go routine that was panicking. So I'm going to go ahead and remove watch so we can see that a little easier. And go up to the stack frame that was actually within my package string util. So I can see the line of code that this happened on. I can look at the locals by expanding this, and I can see that I had J is 12, so this is promising. We had an index out of range error, and I was 0. And if I look at this code, this happened right at the beginning of when I defined I and J. We had 0 and 12. So I can see that I should have had J start at the length of R and -1 and not at the length of R. So I'm going to stop this debug session and make that fix. And now I want to rerun that test case. So I'm going to use another command called debug previous. So that's just going to debug the last test that I ran, or that I debugged. So we didn't stop or have an error, so I can look at the output. We're no longer panicking, but we are still not getting the result we wanted. So now I'm going to go ahead and try to debug what actually happened. So I'm going to set some breakpoints to do that. The first breakpoint I'm going to set is just at the beginning. If I had multiple test cases, this would be one way to stop at the correct subtest, is to set a breakpoint here. And then I'm going to make this a conditional breakpoint, so I can edit this breakpoint and then set an expression so that it will only stop if this expression is true. So I'm going to do if the name of this test case is hello. And then I also want to set another breakpoint. And so I'm going to set a function breakpoint. So if I go here, I can add a function to break on. So I'm going to set this breakpoint at reverse, because this is where like the heart of what we're trying to do is. So I'm going to set a breakpoint there so I can inspect the state at that point. Now that I've set my two breakpoints, I think they're in good places. I'm going to go ahead and rerun that debug test. So first, we've stopped at that first breakpoint that I set. I can look at the variables and see that the name is in fact hello. I expect it to be hello world. So everything kind of looks right at this point. So I'm going to resume execution by using this menu at the top. So I'm going to hit this continue button. And so now we've continued to our second breakpoint. And we can see the different arguments. There's currently no locals defined yet. So I'm going to take another step so we can look. I'm going to make this call stack a little smaller so we can focus on the variables pane. And see that R is the rune slice representation of S. And I can't personally read rune slices. I don't know which character 100 is. So I'm going to go ahead and use the debug console to convert that to a string. So now I can see that I've evaluated this expression and I get the string representation of R. So that's useful, and I actually want to keep looking at that every time I stop. So I'm going to add this expression to the watch panel so I can see what it is at every stop. The watch panel gets refreshed at every stop. And I could also add a variable to watch. So if I wanted to add R, this also can get added to the watch panel by just right-clicking and adding it. All right, so I'm going to go ahead and start stepping through and see if I can figure out what went wrong. So the first thing we did is we were trying to swap the two letters, but instead of swapping them, we ended up with the H at the front, but the D didn't end up at the back. And so for stepping really quickly, it's pretty clear to see that I have a bug in this line of code where I'm assigning RJ to RI twice instead of swapping them. So I can now make the fix to this by changing this to be J. And now I see this yellow line here. So this is a lint diagnostic. So this is something that wouldn't break my code. My code would still compile, but it's warning me that I probably have a bug here. So in this case, the bug that it's warning me about is that I have RJ being assigned to RJ. So once I make the proper fix to swap them, that lint diagnostic goes away. All right, so I've made this test, so I'm going to go ahead now. I think it's all done. I think everything's ready. So I actually want to run the tests for the entire package. So there's code lenses at the top of my test file to do that. So I'm going to select the run package tests. And I can see the output. So I also have test coverage turned on. So when I run the test, it tells me how much of the code in my package I've executed. So in this case, I've executed 87.5% of statements, and all of them passed. All of the tests passed. So that's good. If I want to see which lines I covered, I can go to the source file and see that the lines in green are the ones that I hit, and the lines in red are the ones that I did not. So in this case, it's this case where we would have an error reading in the file. So I might want to add a test case that would allow me to test that flow of execution as well. But there we have it. We've gone through starting a project, through writing tests and debugging those tests. So I'm going to head back to my slides to show how to get started with all this. If you want to see more features, so this was just a small subset of features that the extension provides. Like you could see when I searched for the generate unit tests for function, there were a bunch of other features that I could have used as well. If you want a full list of these features, you can go to our documentation on GitHub and see all of the different features that the extension provides. And now I'm going to quickly go through how to make sure that your VS Code setup is all set up so you can write great Go code. The first thing you want to do, of course, is to install the Go extension. There are actually two versions of the Go extension, Go and Go Nightly. I was using Go Nightly in this demo. So this includes preview features that we're working on. So for example, the debugging features are, the new debugging features are being previewed through the Go Nightly. So they're turned on by default in Go Nightly, and they're possible to use through the regular Go extension with configuration. But if you just want to get the newest features when we think they're ready, you can use Go Nightly and get early access to some great features. And with either of these extensions, it will prompt you to install the necessary tools. So you don't have to worry about remembering that you need Go Please or Delve. The extension will take care of prompting you to install those tools. And that's all I have for right now.
That was excellent, Susie. Thank you so much. As someone that's also, that's new to Go, this is like a great introduction to it, and to see how VS Code helps me as a new developer with Go and all the features that are available to it. So some questions for you if you got some time. How about?
Yeah, definitely.
Okay. So one from the chat was when you were showing that testing and the test coverage, how does that line code coverage work? Like, would you maybe be able to describe? Is that built in? Is that something that comes with the Go extension that just is provided, or is there something else that they need to enable to do that?
It's something that's provided with the Go extension. So if you have the Go extension installed, the way to enable the coverage is there's a command, Go toggle test coverage, and that will enable the test coverage. So you can turn that on and off as you see fit. So if you don't want it there later, you can just easily make it go away.
Excellent. That's great to hear. The usual question you might get quite a bit that I want to make sure we get out of the way too is, what theme were you using?
I was using the high contrast theme.
Right, yeah. And that one's built into VS Code, right? No one.
Yeah.
We don't need to install an extra theme for that one, so that's great. Thank you for sharing that with us.
Yeah, of course.
And then you mentioned linter a few times. So for folks that maybe aren't familiar with what that's about, it seems like it comes built in with the Go extension, but what does a linter provide feature-wise for developers in general?
Yeah, a linter will provide, lint and vet tools will provide, diagnostics or ideas of how you can improve your code that aren't necessarily breaking your code. So you're going to get errors that if your code's not going to be able to compile, but then there's another class of errors of you're using, or in my case, I probably had a bug in my code, or in other cases where you're just not using good style. And these are, so that's what those lint and vet tools provide. And those are also included with the Go extension provided by Go Please. Yeah.
Gotcha. That's super helpful. And speaking of like that bug that you were going through, I had never heard of the term rune slices before, so that was
Mm.
interesting. Is that something specific to Go, or is that a
Yeah,
another term general?
runes are like characters
Okay,
essentially in Go. Yeah.
interesting.
Yeah, and slices are like a list type. Um, yeah, data structure in
I
Go
got
as
you.
well. Yeah.
Cool. The
So
other thing
like,
that Oh, go ahead.
no, go ahead. Yeah.
The other thing that came to mind, a lot of times my questions are derived from my background and experience. So,
Hmm.
my background is coming from Node, and I know that there's another project called Deno that seems to do the importing of other libraries, very similar to what Go is doing there. So, could you maybe describe that a bit more in terms of like what exactly is happening there when we have other libraries or packages dependencies that we're pulling into these projects like that? It's URL based, it seems like, right? So it's not
Um,
something you install, or how does that work?
yeah, so this is a little complicated, so I'm
Okay.
not gonna, get all the way into it. But so, for example, the package that I included was part of the standard library. So this comes with all Go distributions, so I didn't have to do any extra installing of libraries. But if I was to use a package that, for example, you wrote on your GitHub, Brian, then I would have to install that package, and then that would also show up in my go.mod, like included as a dependency in my project, and then I could use the packages that you've written in my code as well.
Gotcha, okay. Very cool. It's really, really interesting to see all this, and I thank you so much for your time to, give us this introduction on how we can use Go in VS Code.
Yeah, of course.
All right, folks, that does it for this session. I want to thank Susie again and the folks in the production crew that are helping make these happen. We hope you enjoyed it and got some value out of today's session. If you missed any part of it, you want to go back and reference some things. Again, these are recorded. They'll be up on the Visual Studio Code YouTube account. Go to youtube.com/code. You'll have access to it there. For future events, don't forget to go to meetup.com and sign up for the meetup group there that we have that will get you prepared for all the future events and the schedules. I saw somebody in the chat asking about schedules for live streams, particularly around VS Code. Meetup.com will help you out there with that kind of thing. And last but not least, there's some fun stuff going on TikTok, tiktok.com/at VS Code. So you can have some fun ways to engage with the VS Code team there as well. Thank you all so much for watching. Hope you have a good day wherever you are in the world. Happy coding.